Finding the limits of polynomial functions is an important topic in calculus. The limit of a polynomial function is the value that the function approaches as the input variable gets closer and closer to a particular value, called the limit point. In general, to find the limit of a polynomial function, you can use algebraic manipulation, limit laws, and the properties of polynomial functions, such as degree and leading coefficient. The process may involve factoring, simplifying, and canceling terms in order to arrive at a final answer. The limits of polynomial functions are used in many areas of mathematics, science, and engineering, such as in the study of derivatives, integrals, and optimization problems. Understanding how to find limits of polynomial functions is an important skill for students studying calculus, and it is also useful for those pursuing careers in STEM fields. Key to remember: in solving the limit of polynomial function, always remember this rule. Number 1. The limit of a sum of two functions is the sum of the limits of the individual functions. Number 2. The limit of a difference of two functions is the difference of the limits of the individual functions. Number 3. The limit of a product of two functions is the product of the limits of the individual functions. Number 4. The limit of a quotient of two functions is the quotient of the limits of the individual functions, as long as the limit of the denominator is not 0. Number 5. The limit of a composite function is the composite of the limits of the individual functions. Example number 1. Find the limit of 3x minus 1 as x approaches to 2. In solving for the limit of polynomial function, the process is similar in evaluating a function which is through substitution. Get the function which is 3x minus 1. Identify the value of x. The value of x is 2. Substitute the value of x to the function. Then, 3 times 2 minus 1. We replace x with 2. Simplify using the MDAS rule. 3 times 2 is 6. 6 minus 1 is 5. Therefore, the limit of 3x minus 1 as x approaches to 2 is 5. Example number 2. Find the limit of x squared minus 4x plus 2 as x approaches to negative 1. In solving for the limit of polynomial function, the process is similar in evaluating a function which is through substitution. Get the function which is x squared minus 4x plus 2. Identify the value of x. The value of x is negative 1. Substitute the value of x to the function. Then, x squared should be negative 1 squared minus 4x should be minus negative 4 times negative 1. Simplify using the MDAS rule. Negative 1 squared is 1. Minus 4 times negative 1 is 4. So, 1 plus 4 plus 2 is 7. Therefore, the limit of x squared minus 4x plus 2 as x approaches to negative 1 is 7. Example number 3. Find the limit of the cube of the difference of 2 times x squared and 1 as x approaches to 1. In solving for the limit of polynomial function, the process is similar in evaluating a function which is through substitution. Get the function which is the cube of the difference of 2 times x squared and 1. Identify the value of x. The value of x is 1. Substitute the value of x to the function. Then, 2 times x squared should be 2 times 1 squared minus 1. Simplify using the MDAS rule. 2 times 1 squared is 1 minus 1. 2 times 1 is 2. 2 minus 1 is 1. 1 cube is 1. Therefore, the limit of the cube of the difference of 2 times x squared and 1 as x approaches to 1 is 1.